we have talked about the input-output system for our C programming language. So now I want to show how we use that in writing our first programs, and we should practice that like I highlighted, that you should download the programming platform and try to write your own programs and practice and see how the system responds to different changes that you make in your program. Okay, so it's very important that you practice that programming even after this course is over, because you still need your programming practice as we go. So you have to again just edit. So introduction to C programming. So the C program language is a structured and disciplined approach to program design. So let's look at our symbol first. First program, right? So include stdio.header. So this is a preprocessor directive which tells the computer to load the contents of a certain file. In this case, the computer will have to load the contents of the stdio header file so that you can perform your standard input-output operations. Then go on to int main. So int is showing us the return type of our program. And in this case, our function that we are talking about is the main function. Okay, so in all C programs, everything that is in the main function is what will be run by the machine. So that means if there is any function that is outside the main, you should make a call to that function so that it can be used. So we have this double, this parenthesis, this and that. So this will form the body of our function, right? So everything or else statements that belong to the main function will be enclosed in these braces. Okay, so printf welcome to C. This is now an executable statement, right? It is now an executable statement. So remember, because of the standard input-output, you can make a call to printf, and it is predefined in this standard input-output header file. So it can be called, and then it will print to the standard output, which is our screen or our monitor, to print everything that is in the quotation marks. But the new line character is not printable. It just tells you to go to the next line. Then return 0, saying if the program is run successfully, it should exit with a 0, right? So when you are writing your comments now, this / and asterisk opens your commenting section, and the asterisk in the / closes the commenting section. So whatever is within these two is not executed, it is ignored by the computer. So it actually helps you to understand what you are doing. That means it improves the readability of your program. Then I have explained why we need the stdio. So the C program contains one or more functions, exactly one of which must be main. Like I said, only those statements in the main function are executed, right? So you have to make a call to any other function if it is not within the main function, right? So we use the parenthesis. This, if it is empty, it means the function takes no arguments or no parameters. Then if there's something inside there, then that means it has to accept those. We'll look at it when we go to more programs, right? So int main means it returns an integer value. That's the return type of our function int. Then this shows the block or the body of our function, right? So everything that belongs to a function should be within those brackets. Then printf will come to see this inside the computer to print, right, a string of characters within the quotation marks, right? So a line that ends with a semicolon is what we call a statement, right? So every statement should end with a semicolon. If you don't put a semicolon, that means it is continuing in the next line. Then our escape character and an n show you that you are putting a new line character. Remember, I explained these escape characters in the previous lecture, right? Return 0 is a way of exiting. If it runs normally, then it returns a 0 and the program terminates. This closes the body of our main function, right? Then there's a linker. When a function is called, the linker locates it in the library and inserts it into the object program. That means the printf, it is made available due to the use of the linker. So when you put your printf, the linker will look for that printf in our stdio header file, then it inserts it in the object program. If you misspell the name, then there will be an error because the linker will not be able to find that function in the library. Let's say you just write print, then it will not find it because stdio header file, there is printf and not print, right? Then let's look at another example. Include stdio.header, like I said, it's telling you to link to the predefined C header file for standard input output. Then int main, we've explained this. You see, we don't put a semicolon after that because this is not an executable statement. Then we open the body of our main program. We declare our variables integer 1, integer 2, and sum. These are of type integer, right? But it is also possible to declare them in 3 lines like int integer 1 semicolon, int integer 2 semicolon, int sum semicolon. But you can do one line declaration separating the variables by a comma so that since they are the same type, you cannot do a single line declaration if the variables are of different types. Then printf enter the first integer. This is printed and you see it, so it is a prompt. You see that when we put something in the / and asterisk, which is our commenting block, it will be ignored, but it tells you what is happening in the program so that even when you are revising or debugging, you know what you are doing. It is very important for you to comment your program, especially when it becomes large. So printf enter first integer, then scanf. We said the scanf will take input from our standard input device, which is our keyboard, right? So %d, it means it will take an integer value. Then asterisk, ampersand integer 1. This means that whatever is taken from scanf will be stored in the address of integer 1. Then it becomes the value of integer 1. This is the reference operator which is here, that whatever is coming will go into the address of integer 1. Then you are prompted to input the second one. Again, the formatting means it takes a decimal integer, then address of integer number 2. That's where your variable will go. Then your sum becomes equal to integer 1 plus integer 2. This is an assignment operation in which the arithmetic sum of integer 1 and integer 2 becomes the value of sum, right? Then printf sum is %d. You are showing that you are outputting formatted output. So %d here, then the value of sum will be put into this position such that your output will be the sum is that. So if you put say 45 and 72, then to tell you that the sum is 117. This is a simple program which does addition, but it is very important to note that you've used printf because you have standard input output, you have used scanf because you have standard input output, right? Then when you use formatted input or formatted output, you have to put the type that will be outputted there. So as before, stdi.header, integers 1 and 2 declared in the same line, right? So these are variable names or the identifiers which we talked about in the previous lecture. Then a declaration of a variable should appear before an executable statement, right? So if you use integer 1 before declaring it, you get a syntax error. Why? Because this will be an unidentified or an unknown variable. So you have to write it first, then you can use it after that. Right? Scanf, we explained this in the previous lecture. It takes from the standard input, which is our keyboard. So here it is taking two integers, one at a time after the prompt, right? So, like I said, this will be pointing to the address of the variable, then its value is put inside there, right? Then the assignment operator, the value to the left takes the value of the variables to the right. So variable 1 plus variable 2 become sum. So you realize that variable 1 and variable 2 are not modified by this statement, but it is the sum which is modified by the statement, right? It is the sum which is modified by the, right? Then also go on to variable declaration, definition, and initialization. So realize that there is a difference between defining a variable, declaring a variable, and initializing a variable, right? So if you are defining a variable like external int a, b, external int c, external float f, here you are just like scoping a variable. So you say there will exist such a variable a and b, right? So if you define a variable, they are not allocated memory at that time, right? But then when you declare a variable now, like int a and b, then a and b now are now allocated memory, right? So here we are just telling that there will exist these variables, but now we are saying these are the variables, they should be allocated memory. Then initialization, you are now saying for the value of variable a, it should now be 10. That means the address of a is the contents of the number, and the number is called 10, or the value is 10. So you are now initializing the value there. So if you don't initialize your value, by default it is equal to 0 if they are integers, or now strings and characters, right? Then b is equal to 20, then c is equal to a plus b, this is similar to the sum that we did. Then print the value of c, percentage d, then c will be inserted there, right? Then f, the floating point variable, 70 over that, print the value of that floating point, that means the value will come with its decimal contents there, right? Then you can also use functions. In other words, in the previous examples, we were doing everything in the main function, right? So this word void, you can skip it in see, because if you don't put anything, again you're just saying it doesn't retain anything there. So here now we are defining a function int min int a. It takes two variables a and b. Then int main void doesn't take any variables, sorry, so it doesn't take any variables. Then we are declaring our variables j, k, and m. Then printf input two integers. Now you see that in this case, the scanf is taking two variables at once. So you enter the first one, then you strike enter the second one without a prompt, right? Then m is called min j k. Now when you say min, this is now a function because of this parenthesis, shows that what we are calling is a function. So your linker should find this function called min, and it will find it here, right? Then it takes the variables a and b. So in this case, our j will be equal to our a, our k will be equal to our b. Then it's now comparing if j is less than k. Remember, I said the value of a will become j, the value of k will become the value of b will become k. So this will be value of say 1 and 2. So if a is less than b, return a. That means it gives you the output of a, right? Else return b. Okay. So what is retained here now is what will come in there, right? So you can see that when we make a call to this, we've jumped out of the main program and went to the function min. Then we run it, we take whatever it returns, then we go to the next instruction, which is printf new line of the two values, %d, %d. The minimum is %d. Then the first value is j, so j comes in here, k comes in here. Then the minimum is m comes in here, right? Then return 0 and you exit. So you realize that this program will end at this point, at the end of the main, but it can run any other functions that are outside the main as long as you make a legal call to that function, right? That's why here we had to define our function, right? Then we make a call to it here. This is where the function is declared and implemented. Then you go back to that. Okay. So this will print space of float variables and their range of values. Now it includes float.h, which is a header file. Why? Because there are some functions which belong or which are found in the float header file, which you want to make a call to. That's why we have to explicitly include that float. If you don't include this, then this float max, float minimum will give you errors. Why? Because they are not defined anyway. They are not defined in the standard input output, and there's no function that is defining them. That's why we need to include this data file. So in other words, we are just directing the linker that we also want to have access to float. So when you make a call to these values now, it will be able to get to them. That's why we have to explicitly define any data file that we are to be using, right? So let's try to understand what we are talking about when we talk about variables. So a variable name corresponds to the locations in the computer's memory. Every variable is a name, type, size, and value, right? Usually the type will also determine the what? The size, okay? Then the value is what you put there. So whenever a new value is placed into a variable, through scanf, for example, it replaces the previous value. So you override the previous value if you assign a new value into a memory location, right? So let's say we have integer 1 is called. Then you say now integer 1 is equal to 37. Then the 45 is overwritten and the new value becomes 37. So what happens with our arithmetic calculation is just a revision because we did it. So this asterisk is what we use for multiplication, then this for division. Then if you divide in this way, it returns the integer and not the comma. But if you divide with the percentage here, it gives you the remainder only, and not the integer, right? So it's only the float variables which will give you 1 point something something. If you do integer division, then the remainder is excluded. So whether it's 1.5, 1.7, it doesn't round off. It just takes it off. Okay? So that's why maybe you say 8 over 5, right? Get 1 not, instead of 2 because it doesn't round off, right? So some arithmetic operators act before others, right? This is your BOMDAS and like the way you do it, multiplication, division, whatever, that's the same thing. So if you say a plus b plus c over 3, definitely it will evaluate c over 3 first, then a plus b plus c over 3. If you want to divide everything by 3, make sure you put your brackets, then here you'll be dividing by, right? So these are arithmetic operators. Okay, don't have to do much on that. Multiplication, division, the like. Don't think we need much about that. So we also have to go into the structures which are used for decision making. In other words, we want to evaluate a certain condition. If it is true, we see what to do. If it is false, we see what to do. So in this case, we'll take an example like of the if statement, right? So let's say if not equal to, if equal to, if greater than, in the like, just like you say in English, if A is greater than B, print D or whatever. That's exactly what we are talking about here. So these are our relational operators. This tests for equality. The two are totally equal. This, if they are not equal, this one greater than, less than, greater than, or equal to, less than or equal to statements that we can do, right? So let's see how we use an if statement. Standard input output and the like, declaration of our variables, prompt to enter your variables as usual. Then if first number is exactly equal to second number, you write this is equal to that. So num1 is equal to num2. If not equal to, num1 is not equal to that. If num1 is less than num2, you say num1 is less than num2. If num1 is greater than num2, right? If less than or equal to, and the like. So it's just like an English statement, but you realize that the if, then this is the important comparison that you are talking about, which gives a Boolean output. It's either 1 or 0, 1 for true, 0 for false. So it means if this is false, this statement will not run. Okay. Why? Because if you look at the if, it doesn't end with a semicolon. The semicolon comes here, which means this whole thing is a single statement, right? Up to there. So if this is false, this will not run. If this is false, this will not run. But if it is true, then it continues until it completes the statement, right? And if num is greater than or equal to num2, you write that. Return 0 if program ended successfully. So these are just examples of what you can enter and what you can get as your output, right? Then the if selection structure, this is what we call a pseudo code, just English like code. So it's not proper C code. You should be able to convert this to proper C code. If student's grade is greater than or equal to 60, print passed. So if the condition is true, then the print statement will be executed, right? And the program goes to the next statement. If false, the print statement is ignored and the program goes on to the next statement. Indenting makes programs easier to read. It doesn't change anything. C will just ignore the white characters. So the pseudocode, let's say if grade is greater than or equal to 60, printf passed. Remember, our semicolon will come at the end of the statement, right? So this is almost a correct C program, except that we have not defined the grade. So if we had defined the grade or declared grade as an integer or something, this would be part of the program that would run using the if selection statement, right? So if it was a flowchart, that's where we use our diamond structure. If yes, go there. If no, go there, right? Sure. You learn this in your flowcharts, right? So if structure grade greater than equal to print past, false, you do nothing, right? This is the same thing, but you can also have more than one if statement. So the if else statement, remember we said if you say if and the condition is not true, then it does nothing. But sometimes if you say if, you want to say otherwise there might be this other condition which might be true. So in that case you can use the else statement. If student grade is greater than 60, print passed, else print failed. Right? So I'm now saying if it is not greater than 60, we are now going to print failed. Now in if else statement. So in C, if grade is greater than or equal to 60, printf passed boolean character you end here, or else. That means if this is not true, then print this. That's what the else statement is saying. So if the first condition is not true, go to the next statement, right? Then there's the ternary conditional operator, is this question mark, right? So printf %s in grade greater than or equal to 60 passed or failed. Okay, so what is happening here? It's saying, is this condition true? If yes, you print that. If no, you print that. It's almost the same thing, but that is done in one line because of this, right? It's still the same statement, right? Still the same statement. So this is still identical to the if else statement, but using this ternary operator. So that's the same thing. Go this way or that way. Then you terminate. Then there are also what we call nested if else statements. This tests for multiple cases by placing if else selection structures inside other if else selection structures. So if one condition is not met, the rest of the statements are skipped, right? If student's grade is greater than or equal to 90, print A. So if it is not greater than 90, that's the else. So this else is for that. Then do this test. If it is greater than or equal to 80, print B, right? Or else if it is not greater than that, let's do another test. So this goes with that, this goes with that, and this goes with that. So the each if is its own else, it's else, if else, right? That's a nested if else structure. So In other words, it tests this. If it is not true, it does another test. If it's not true, it does another. Okay. So we talk about the block now. That's the body of our function, which is statements with declarations. Syntax error is one which is caught by the compiler. That means the program will not even execute. Logical error is now come after execution, and they usually give you wrong output. Those are now logical errors, right? So there's a syntax error whereby you can say wrong punctuation. Then logical, that becomes how you have defined the flow of your program, right? So this does not run. This will give you some runtime errors as the program is running. You might get wrong output, right? So the nested control, explain the word how this works. Then we have int I. Enter an integer number, scanf, so we enter I, then we start testing I. If I is greater than 0, right, let's say it's true, and if I modulo division by 2 is equal to 0, that means if I is divided by 2 does not leave a remainder, then you print is an even number. So the first condition, if it is true, that's why you go to the next statement. If this is false, it jumps to the else statement, right? Printf %d is an odd number. Why? Because it doesn't leave a remainder, right? Then else if, right? So you see there's an if and it's else, right? If it leaves a remainder even, else it's odd, right? Then if this if, yes, it's on else there. So else if I is equal to 0, print is equal to 0. Then this if, yes, it's on else here, otherwise print is a negative number. Why? Because it will fail to satisfy the condition that should be greater than what? Than 0. So the nested if statement will become very complex if there are many decisions that need to be made. However, sometimes the programmer will have problem following the complex if statements. So there are other ways of writing these statements which are very easy. Let's say there's one condition that we want to check on a certain variable, right? This is where we use the switch case statement. The switch case statement, remember one thing, the case should be one variable, right? So we are testing whether A is equal to B is equal to C or the like, and then we see what to run. So this is what we are switching to one variable. Case number 1, if it is 1, do this. If it is 2, do this. So you realize that instead of following the if else, you can use case 1, then you break. That means if this is true, then don't check any further, right? So it goes to the case, finds case 3, then it ends there, right? And runs to the that's the break, the use of the break statement. That means it should break the execution once it meets the condition, okay? But if it doesn't meet it, then it will go to run the default, which means that none of the above conditions were satisfied, and then it breaks or ends, right? So it's breaking the switch statement. Find a case. If this is true, break means you are breaking out of this structure and you are running to the next, which is the return. As you can see, the switch is actually like a function. That's why it also has its own braces. Okay, because it's a predefined thing in C. Right? Assignment operators. I think I talked about this. Then incrementing and decrementing. I talked about this also. There's pre and post incrementing. Increment C or decrement C, right? So you change the variable before it is used in the statement. Here, you change it after it has been used in the statement. Okay? If C equals 5, then plus plus C, right? That means to give you what? 6. Okay? Then if C is called 5, printf, then it is C plus plus, right? So here it will print to do the operation after the statement, right? Then it gives you that. So in that case, C now is the value of 6. So in this case, there is not much difference, right? So yeah, incrementing. Here you are pre-incrementing, right? If C is called 5, printf it plus plus C, that means same as 8 1 to C, right? Then here it's saying 8 C plus 1. So you realize that in this case there is not much difference between this